first, what goes second. It follows what we call the Aufbau principle, which it starts at the lowest level first, and then it moves up into more increasingly higher energy levels and sublevels. Okay? So this is going to be on every single screen I have from now on. So if you're like, oh, I didn't get it yet. There it is. So as we're finishing this up, what I'm going to do is we're going to do 3 examples today. First one's boron, then phosphorus, then iron. After that, I think you're going to feel very good about this. Again, what are we doing? We are placing electrons where they are located when they are at the lowest energy level. Okay, so first one's boron. If I take a look at the periodic table, boron is number 5. I don't have a charge on here, so protons would equal electrons. So I don't mean to have that negative there. You have 5 electrons. I have a little spot where you can write that. Please write it down. It is very important that you know how many electrons are in any element that you're placing the electrons on, because you need to know how many you need to put into the diagram. So you do not have a lot of space here, but don't put it right below electrons. Move it over just a little bit. What we are going to do is we are going to do what is called an orbital diagram. So I am following my arrows. And just stay with me, and you're going to understand it very quickly. Before we go, on your cheat pyramid, let's do this. I don't have it written down. Underneath the S's, put a little parenthesis and put a 1. Because we have 1 S, right? How many P's did we have? We had 3. So put a parenthesis for 3 under the P's. And then we had 5 and 7, right? 1, 3, 5, 7. Put numbers underneath your cheat pyramid under each column. That'll help. So I've established that S is 1. Why? Because I have one single shape that it can have in 3 dimensions. So what I do, way down on the bottom, make a line. Don't do it right underneath where it says electrons. Go over a little bit. But in the boron area, write 1s. And now we're going to place electrons on there. Again, I'm telling you all the rules as we go. Instead of writing them all down, we're going to practice them. You're going to do an up arrow. Instead of doing an actual arrow, do a little flag. So you start up, and then you go halfway up, and then you bring it all the way down. That is considered an electron. That's how we write an electron. So that's 1. I have 4 more to place. I have to place 5 total. Another rule, which we don't need to talk about each and every single little rule, but electrons, they have a certain spin to them, let's just say. Okay, so if they're spinning one way, they're maybe making like a north or a south kind of a polarity. So the other one has to offset that. So if you have one going up, the other one has to be going down. And right there is another little mini rule, is that every line can only hold 2 electrons. So I have filled my 1s. I have 3 electrons to fill yet. So I can't do any more. A line only can hold 2 electrons, up and down. So what do? I go to the end of my line. Oh, the line's done, so I go to the top of the next line. It's a 2s. That's a new energy level. So I write it above, but it's still an s, so I go right above that one. So make that line. So I go 3 and 4. Okay. So now I have 4, I have 1 left. So I look at my cheat pyramid. In my cheat pyramid, I end my arrow again, so now I need to go up to the next arrow and it says 2p. Notice they're next to each other. A 2 is the same energy level, and how many lines do you think a p has? If an s has 1, a p has 3. So what I need to do is, please, you got to put brackets. You got to say all these lines are with the 2p. If you don't do that, then what we have to do is actually write 2px, 2py, 2pz, because you have to say what each one is. This is a faster way, so don't be lazy on the brackets. And I needed 1 more electron, so there it is. There's my last electron. That is 5. Now, what the heck am I even looking at? I don't get it. Well, let's talk about the anatomy of this, because it's the same for every single orbital diagram. You don't have to write the word energy. Just know as I go up, as I go to each number, as I move through this, each one gains more energy. Every number, can't fit it right there, then point it to the number 2. Every number is an energy level. Okay? Every letter is a sub-level. So energy level 1 only has 1 sub-level. It's an S. Energy level 2 gets 2, 3 has 3, 4 has 4. Technically 5 has 5. We start getting into these huge G's and H's, which I can show you later. I have a cool website that I found that shows these crazy lobes and electron clouds. Every line is an orbital. So that's an orbital, a P has 3 orbitals. I know I probably didn't give you a ton of space, but I have faith in you. If you want, you can label every flag as a little electron. And then finally, just so you understand it, when we start labeling and talking about it, if you put it up, we're calling that an up spin. Even though technically it's not like it's an up spin, it's more about like a north and a south polarity. And the other one's a down spin. And that is in orbital diagrams. Electron configuration. You're going to like these. This is the harder part. The electron configuration is like a shortcut. It's a summary of what you just did here. So what did I start with? I started with 1s. How many electrons do I have in there? 1, 2. So I write 1s2. That's not 1s squared. It is a smaller number. It's a superscript. But it's 1s2. That's how you say it. Then I go forward. Oh, that's 2s2. And how do I end it? You've never even done this before, and I bet you know how to end this. It's 2p1. Because there's one electron in there, right? 2 plus 2 plus 1 is 5. So when you're done, those little numbers should equal the number of electrons I have. Okay? All right. We need to compare and contrast. So hopefully you have that down. I'll give you about 10 more seconds. We're going to move on to, is it phosphorus? P? Yes. Okay, so phosphorus is number 15. Because it doesn't have a charge, I should have 15 electrons. So please fill that in. Now, I'm going to show you something here. Let me go back for a second. This is all fine and good, you guys, going up. But when I'm doing a worksheet or on a test, and what if I got to do a lot more of these, and I only have that much space? I'm going to run out. So the next two problems, what we're going to do is we're going to start this one up here, and we're just going to go downward. So it's actually going to kind of look like this, like the 1s here, the 2s there. We're just going to flip it. So instead of energy going up, the energy is going to increase going downward to save space. Let me show you what I mean. So I'm going to cheat. I'm going to tell you why. That's what we just did. I want to continually prove to you that the format is the same. It's just how many electrons you have. That's always 5. It's not like, oh, now magically the first 5 are different in this one. It isn't. So if you're not writing this down yet, write it now. Notice I'm just going downward instead of upward. Why? Because I don't know how much space I need. I don't want to run out of space. So usually we do it this way. So I'm at 5. I need 15. And if you're like, that's impossible. You are going to fly through these eventually. A habit that I want you to get right away is that when you have multiple orbitals, I want you to fill them all first and then come back. I will talk about that at the end. So you go up, 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 and then you come back going down, down, down. Okay? Well, we'll discuss it in a minute. So that is now 10, right? 2, 4, 6, 8, 10. All right, let's take a look at our cheat pyramid. I'm at 2p. Where do I go to next? 3s. Where do you think I write that 3s? Down here, right? Each number is a new level, and then I line up my sub-levels. So 3s should go right here. So I'm at 10, 11, 12. Right, every line's worth 2 electrons. After 3s, oh, I'm at the end of my line again. Go up to the next line. Oh, 3p. It's on the third level. It's in the p column. So I write a p. P's at 3 lines. And I have how many left? Don't I only have 3 left? Please. This is the last law that I have to teach you, and hopefully you can fit this in somewhere. It's a really important one. It goes up, up, up. Not up, down, up. This is called Huns Rule. Fit this in somehow, some way. Imagine, let's say you're playing soccer in the muddiest, coldest weather you could have possibly played in, and you get on the bus right after, and everyone's just full of mud and it's soaking wet. Everybody fills the bus. You probably are going to each of your own seats. And when you're young, when you were really young in elementary school, you guys all want to sit next to each other. Now you guys are a little big. Those seats are a little small. So you all fill your own seats first. Then the last 4 or 5 teammates come on and there's no more seats left. Now they start pairing up and they start sitting with other teammates. Electrons are naturally negative. If possible, they're not going to pair up. They repel each other. So unless they're forced to pair up, they're going to stay apart. the best way I can say it at the ending of all this is that this is less stable than this. They have figured out if the electrons stay apart and fill every orbital, it's more balanced, and you don't have that natural repulsion. So it's more stable. So if you get into a habit, if I just go back for a second, of when I'm filling this up, if I go up, 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 down, 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 instead of going up, down, up, down, up, down, if you get in a habit of just going up, 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 you'll never make a mistake. For example, if there were like 4 of these, you'd go up, 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 down, and then it'd be done. It would look like that, right? Instead of going up, down, and you're like, oh shoot, I gotta erase these and start over because I didn't follow Huns Rule. So if you just go up, 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 and then down, 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 you'll be good to go. All right, let's talk about electron configuration. Same idea. So I have 1s, and there's 2 of them. I have 2s, and I have 2 of them. 2p. Now, the more you do this, the quicker you're going to be, because you don't need to count these. There's 3 lines. Each one has 2, right? So it should be a 6. So 2p6. I have 3s2, and it's going to end on what? 3p3. Yeah. Great. And that's the electron configuration. All right. We could do something crazy today, like let's do 70, but there's no need right now to do that. So we're going to go to one more. It's iron. It's element number 26. Because it's number 26, and I haven't told you that it has a charge, that means it has the same number of electrons. We'll get into charges later. It's not an ion. So I have iron. It's 26. Again, let's establish something here. Like, slow down. I am. What I'm just doing is, hey, I just did one that was 15. I need to get to 26. That's 15 right now, right? Why not start the structure? And I'm actually going to ask you to eventually memorize up to 18. If you know that 18 is 3p6, I'm not giving anything away there, you can kind of work off of that really well. We're not going to be doing a lot of elements that are really huge necessarily, so the more you're just understanding that beginning part, the structure of it, the better off you're going to be. So I'll give you a second to catch up. So I got to go back, and that's 16, 17, 18. All right, now this is where your cheat pyramid is so important. What comes after this? 4s. Wait, what? Why not 3d? 3d has 4 electron clouds in it. It's very complicated. Has 4 of them in just one, by the way, in just one d orbital. And then there's 5 different ones. This is just one of them. There's 5 different configurations of this. Or there's an s orbital that's simple and much lower energy. So just because this is maybe the 4th energy level and this is the 3rd energy level, energy-wise, this is more energy to be in it than this one. Oh, I got to memorize that? No, you don't. The cheat pyramid does it for us. So the cheat pyramid is going to help us figure out the order. So I got to do 4s next. Hopefully you have an understanding where you're probably going to put that already. Right? It'd go under the 3s. Right? We line up the columns, and the rows are your energy levels. So I have 19, 20. All right. What is next? 3D. Where is that going to go? Below or to the right of something? To the right here? How many lines does it get? How many orbitals? 5, right? 1, 3, 5, 7. So I'm going to make, oh gosh. It's okay, you'll make it, you'll survive. None of my limbs have fallen off yet, and I've had to make a lot of these. 3D, very important. We have 6 left. We were at 20. By the way, that's another big thing, you guys. Knowing that 3P right here is 18. If you ever lose count, you can come back to that. It's a good anchor. I hate losing count. You do it. I do it all the time. Oh my gosh, wait, how many did I have? Know that that's 20 or 18. Oh yeah, 19, 20. All right. So I need to do 6 more. It's not up, down, up, down, up, down. Right? It's up, 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 up. Come back once, down. So what I'd like you to do is I'd like you to do the electron configuration. But don't worry about this. Don't worry about the cheat pyramid. Just literally follow the rows. They don't have to be complete. If you did follow the cheat pyramid, it would still be correct. Whatever you write is correct based on your orbital diagram. But see, you should be able to do the electron configuration. Give it a shot. So as you're finishing up, I have 1s2, 2s2, 2p6, 3s2, 3p6. Now, if you did do the 4s2, I feel like you just actually did more work for yourself because you had to try to track it. It doesn't matter what order you put this in. You've already placed them where they should be. So this is 3d6 and 4s2. If you flip these, it's right. If you got crazy and moved these all around, technically it'd be right, but there is a point where if you're like, I'm going to do 4s2 here, and I'm going to do a 3d6 there, and you start getting it way out of order, and we got issues. So I like to go from the lowest energy level, and then just sweep through the rows. Sweep through the energy levels as you go. That is how we place electrons. Already, I hope, at least you see some similarities and some differences from one to the next, but it's the same framework all the time. So when do you have to worry about an F? You don't have to worry about an F until way after 6s. Just so you know, that is 57 electrons. We hardly ever get to that. That's a long ways. By the way, why did I know that? You're very shortly going to know how to read the periodic table, and I know where all these letters are located. It's actually really, the periodic table is this cheat pyramid, and it'll be really useful for you.